In this video, I am going to discuss all the points regarding the cylindrical coordinate system. Now, in the last video, I have already discussed about the three different coordinate systems in which a point can be represented in the three-dimensional geometry, right? So, in this today's video, in this video, I am going to discuss about cylindrical coordinate system. Now, if you know how a cylinder has been formed, then you can easily understand the formation of a cylindrical coordinate system. Now, the best example that I can give you for a cylinder is a pipe. Okay, so if you take any water pipe, it is an example of a cylinder. Now, or else a pen stand if you take, or a pen. So, these are all examples of cylinders. Now, let me explain you how a cylinder has been formed and rotate it in the ground plane by 360 degrees. Okay, so keeping the center constant. Rotate this radius vector in the ground plane by an angle of 360 degrees. So, what is the tip of this radius vector describing? It is going to describe a circle. Okay, are you understanding my point? So, here it is describing a circle. So, this the circle that is described by this radius vector is lying in the horizontal plane. Now, this circle in the horizontal plane, you extend it in the vertical plane like this. Okay, so what is going to happen? Which three-dimensional object is going to form now? By extending the circle which is formed in the ground plane and extending that in the vertical plane, you are going to form a cylinder. Okay, so I'll show you the pictorial diagram here simply so that you can easily understand. Now, you are going to describe a cylinder like this in the ground plane. So, this is what actually, this is the circle which has been described by the radius. So, this would be your radius actually. Okay, so this would be your radius rho. Okay, so this would be your radius rho, and this is going to be extended in the vertical plane like this. So, let us extend this in the vertical plane. So, this is your cylinder which is formed. Okay, this is the three-dimensional object which is formed. So, this is a cylinder. Now, this is rho. So, if you observe in cylindrical coordinate system, the rho is measured in any plane parallel to the horizontal plane, or if you take this for example, if you take this particular plane, so it is exactly parallel. So, if you observe, this is parallel. Okay, so this rho is parallel to the ground plane. Okay, now what is rho? Rho is length of the radius vector measured parallel to horizontal plane or ground plane. Next, what is phi? So, we have got one angle. So, I told you rotating by an angle 360 degrees. So, one angle is also there. So, this angle is nothing but if I am taking that this is the reference horizontal. Okay, so let me say that this is the reference horizontal. So, from this reference horizontal, how much angle it makes? How much angle a point makes? That means this angle is your phi. Okay, so if I'll show you separately. So, if you take this is the reference horizontal for you. Okay, and with respect to this direction, reference horizontal, how much the radius vector makes an angle, that angle we are going to call it as phi. And lastly, z. So, z is obviously the height from the ground plane or horizontal plane. Okay, so phi is angle made by radius vector with respect to reference horizontal. And what is z? Z is distance between P and horizontal axis, or I can say the horizontal plane. Okay, so distance between the point P and horizontal plane will give you z. Okay, so any point in cylindrical coordinate system can be expressed as P, rho, phi and z. So, this is the point representation of any point in the cylindrical coordinate system. Now, let me explain you about the increments. Okay, now let me explain about the increments in cylindrical coordinate system. So, let me say a point P is moved from rho phi z to P dash rho plus dr, rho plus d rho, phi plus d phi and z plus dz. Now let us evaluate the increments in all the three directions. So, delta rho, which is the increment in rho direction. So, every top Dick and Harry can easily tell that it is final point is rho plus d rho and initial point is rho. So, by using the distance formula, under root of x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. The first coordinate will be obviously d rho. Okay. Okay, and coming to delta phi. So now let us evaluate the increments in phi direction. Okay. Now how to determine the increment in phi direction is very important. Now as I told you, this angle is phi. So what is phi actually? Phi is the angle measured from the reference horizontal. So this is your reference horizontal with respect to the phi, with respect to the radius vector. So rho is the radius vector here. Now I'll show you separately. So this is phi initially, and it has moved to a new location, the point P, which is what phi plus d phi. So if this is phi, this incremental angle would be d phi. Okay, this incremental angle would be d phi. So this would be the incremental length due to this incremental angle d phi. So what would be this length actually? I want this length actually. So how to evaluate this length, I'll show you. Okay, so I'll show you how to evaluate this particular length. So I want this length. So it is, if you observe, this would be a part on the circle. If you observe, okay, so this is d phi. I want this part, right? How to evaluate this part? Since it is on the circle, it's a portion on the circle, it is a sector. And what is the formula for length of a sector in your lower classes? S is equals to r theta, where theta is the angle subtended by the sector at the center of the circle, right? So using that relation, I can say S is equals to r theta. So here what is the radius? Radius is rho. And what is the angle subtended at the center by this arc? Actually, if you observe, it is nothing but this arc, the angle. So it is d phi. So rho d phi would be the length of the arc. Okay. Next, lastly, how to evaluate delta z? Now delta z is, z is also a distance, z plus dz also a distance. So directly I can apply the distance formula there. So by z2 minus z1 would become simply z plus dz minus z. So it will give you dz. Okay, so once you got these increments, it is easy to evaluate dl. So how to evaluate length of the incremental length dl? Simply use the distance formula. So it is simply delta phi whole square, that is d rho whole square, plus rho d phi whole square, plus lastly dz whole square, or simply dz square. Okay, so this is the expression for length. Okay, now let us evaluate the incremental length in, incremental volume actually. Okay, so let us evaluate incremental volume. So what is incremental volume actually? The expression, it is delta dv equals to delta rho into delta phi into delta z. So it is the product of the three incremental lengths in the three directions. So in phi direction, in the rho direction it is delta phi, in the phi direction it is delta phi, in the z direction it is delta z. So it is simply multiply them. So what was d rho? What was delta rho? It was d rho. What was delta phi? It is rho d phi. And what was delta z? It is dz. So if you collectively write this expression, it is rho d phi dz. So this is dv. Now the beauty of this equation is, from this equation only we have derived the volume of the cylinder as V equals to pi r square h. Okay, so how I got the volume of the sphere formula, volume of the cylinder formula as pi r square h? It is by this formula. Okay, so let us integrate this. So V is equals to triple integral. Why triple integral? Because there are three variables. So r varies from, rho varies from 0 to r, phi varies from, so since we are going for a cylinder, it is 0 to 2 pi, and lastly the other variable is z. So z varies from 0 to height h. Okay, so now let us integrate this. What is it that we have got? Rho d phi dz. So what is the integration for rho d rho? It is rho square by 2 from 0 to r into phi. What is the integration for phi? It is integration for d phi, it is phi. So from 0 to 2 pi, and for integration for dz it is z. So z from 0 to height. Okay, so it is r square by 2 into 2 pi into h. So 2 gets cancelled. So you are remaining with what now? pi r square h. So this is how I got the volume of this cylinder as pi r square h. So this is the derivation part for pi r square h. Okay. So with this we have completed the discussion on cylindrical coordinate system. So please do subscribe and support us for your encouragement and doing more and more videos. Thank you all.